Hi, my name is Fei. This is my final project presentation for the course Principles of Big Data Processing at Harvard University Extension School. My final project is processing and analytics of New York City taxi trip data. This is my presentation outline. Project goal, data source, architecture and technologies, implementation overview, result, and then a short demo. So the goal of our project is to build a big data system that can visualize spatial temporal patterns of taxi activities with indexed taxi trip data. And it can also make predictions on trip duration based on machine learning of taxi trip data. The data source is New York City green taxi trip record data. Green taxis are one of the two major types of taxis in New York City. They operate in certain areas of NYC. Data are stored in CSV format. Each CSV file corresponds to a month. The data from February to May in the year of 2016 are used in this project. This is an example of the CSV file. It has fields like pickup time, drop time, pickup latitude, pickup longitude, drop latitude, longitude, and some other fields. The taxi trip data are stored into HDFS, and from here, there are two paths. The first path is to index data into Elasticsearch and visualize them in Kibana. The second path is to build machine learning model in Spark. Let's take a look at the implementation overview. First, I download the CSV file, the 4 months green text data, and copy them into HDFS. And then I index text trip data into Elasticsearch using ES Hadoop Spark connector. Specifically, I load the trip data as RDD, and each trip record is translated into a document. Then I visualize the taxi activity aggregated by space, time, and by space-time plus time in Kibana. Finally, I built a regression model with text trip data using Spark MLlib. I derived some new features, time of day, pickup location, geohash, drop-off location, geohash, distance from the raw features, and I built a random forest regression model to predict trip duration using those features, and then evaluate and save the model to HDFS. Let's move on to results. So this slide shows the result of the visualization tier. The heat map on the upper left corner shows the density of pickup in New York City. This is aggregation, is visualization of aggregation by space. And the bottom the graph in the bottom shows the visualization aggregated by time. So this is the daily activity of the pickup. So you can clearly see a cyclic pattern, like 7 days of one cycle, and this one is an hourly pickup. This one shows a visualization aggregated by space and time. So this slide is a result of the predictive analytics layer. I predict the trip duration, use time of day, pickup location, geohash, drop-off location, geohash, and distance for Tuesday. So I build a model for each individual day separately. So the root mean square error on test data is 424 seconds. The mean absolute error on the test data is 273 seconds, which roughly is 4.5 minutes. And here are some sample predictions. So some are match very well with the actual duration. Some are kind of far, a little bit far from the actual duration. Okay, let's go quickly through the demo. So let's go through the code first. So this is a code for indexing the trip data to Elasticsearch. So you can see I read a CSV file and then convert them into document and put them into the Elasticsearch using Elasticsearch Hadoop plugin. And this is the code that built the machine learning model. So you can see I read the raw data and do some transformation of data, creating some feature set, and build a machine learning model using those features, and then evaluate the model and save the model out to HDFS. Let's quickly look at visualization. So this is one of the visualization for the visualization tier. So you can see I create a filter pickup hours 7, which means I want to show the 7 o'clock pickup activities. This is a heat map that shows, okay, at 7 o'clock, which location has the highest pickup activities. Okay, that's the end of my demo. Thank you.